I'm just coming into this biohacking world to some extent, and you have been in it for ages. It seems, I mean, your entire career has been a combination of, you had GSK from the pharmaceutical side, then you had nutrition, now you're into photobiomodulation. It seems like you've spanned the gamut and our wealth of knowledge, both from a research standpoint, but also just doing your own studies. So for you, I guess maybe just start with, what does health and health optimization look like to you? Or what does this movement mean to you?
The biohacking movement, I think really what it is, taking responsibility for your health. Because we're kind of in an age where, like people tend to get sick, they go to the doctor tells them what to do. It's usually a pharmaceutical intervention because that's kind of where we're at in medicine at the moment. And then, you kind of take your medicine, go back to the doctor, see if you're better, And I think biohacking is a bit of a move away from that. It's a move more to responsibility for your own health, and not only maintaining your health, but to try and get to your optimal, rather than just kind of trying to maintain not being sick. I think biohacking is an actual movement to try and actually see how you can go from where you are to better. How can you actually upgrade yourself? How can you make your immunity even stronger? How can you kind of make your body stronger, build resilience, not just physical, psychological resilience too. So I think biohacking for me is that. It's a lot of people who are coming together who are interested in being a better person, or even like trying to up their game, if you like.
Yeah.
And I think the other interesting thing about biohacking, certainly from a research point of view, is collecting data on what you're doing. So in order to tell whether you've kind of made a difference to yourself, like having some kind of baseline and then seeing how you can push that forward, however that is. And, some people may have very numerical ways of doing that, or metrics or watches or gizmos. And for some people, it's just having that awareness of where you are so that you can kind of make a more intelligent kind of estimation of your improvements. So to me, that's why I love biohacking, for those reasons. It's kind of, not only is it about health, but it's also about health optimization.
Yeah, I love what you said there, because it sounds to me, it's almost that you are starting to take control of your own health, and using this dashboard or using these metrics or using these baseline to say, this is where I'm at today, and then this is where I potentially can grow to. What I think, to me at least, is also, it's not about becoming a hypochondriac and always saying, okay, I'm always going to be hacking something, I'm always changing something. It's just saying, okay, well, yes, I'm starting to feel croaky in my joints. Is that necessary? Do I have to live that way? Or if you look back in Ayurveda, they often say that you should have full range of motion up until your 80s. You should be able to live healthily, and one day, yes, we all are dying. I get that. But we don't need to have 30 years of prolonged misery and death in that way. You could live a full range of life, full range of motion, full range of health, if you just do these little hacks or these little changes in your life.
Yeah. And you can aspire to that, maybe, for some people that's a long way off, being totally and utterly mobile till you're 80. But if at the moment you're struggling to walk up a hill, you can certainly set a goal for kind of bettering that next time, So I think for a lot of people, like I say, there's different targets, what you're trying to work on, but there's always little improvements that you can make.
Yeah. Yeah.
To your health, to your wellness, to your mental state.
Mm-hmm. Yeah. What was a major reason for your shift from GSK into nutrition, or into looking more into where you're at now, a photobiomodulation, which is a complete shift away from pharmaceuticals?
It's a shift away, yeah. I mean, I spent quite a while, like you say, in GlaxoSmithKline. And there I was looking at all different things. And I was mainly looking at asthma, but I was also looking at how the body responds to drugs. One of my last projects was looking at how does they had an issue in that some people weren't getting a result from a particular drug. And it was because if you build up a static charge in your body, you get a different deposition of the drug in your lung because you have a different charge in your body. And so I was on a task force to look at this. And of course, the outcome was, they selected different plastics and, they kind of solved the problem. But for me, it got me thinking, okay, so it's really about the body, not about what the drug so much. The state of your body is having a huge impact on, how you respond to this drug. So it's not,
So when
It's
you say
more,
static charge, I mean, what does that look like? So basically you're saying if somebody has a different static charge, then the drug is going to have a different impact on how it affects them or not, correct?
it is. And if you think about, I mean, that this is why, I mean, it's so interesting that I kind of got obsessed with charge, and then I kind of went to a company called Supercharged. Now I'm in a company called Recharge. It's kind of like reiterating in my life that it's all about charge. And if you think about the body in terms of charge, in terms of physics, you know, it puts a different slant on it. But with regards to electrostatic charge, you know, there's a lot of water in the body. And especially around the lungs, there's a lot of water. And so if you have like an electrostatic charge on that, you can imagine that if you have a powder that's charged, you can think about even talcum powder or something. If you put it, you can kind of feel a charge. If you put that inside your body and you've got all different charges in your body, it's going to stick in different places.
Mm-hmm. Mm-hmm.
So if you have an unhealthy charge in that you haven't, you know, you've got a build-up of charge in your body. And this is where all the grounding stuff is very interesting, because that's about how you can discharge all this excess charge and kind of become, you know, much more harmonious in your body charge. But it does have a big effect. You know, so if you are someone who's kind of, you know, skidding around on your nylon carpet all day and never going outside, you will build up a charge in your body. And that will affect how particles that you breathe in, you know, even pollution and things, that will have a different effect on you, because your body has got this buildup of charge. And really it's from this, you know, the whole paleo movement is, you know, we didn't really evolve to this life. This kind of very indoor life we lead is not really one that we're adapted to. And so we do have these kind of modern day problems, you know, of being indoors, of seeing blue screens, of eating processed food, that are fairly new problems. And our bodies just, you know, aren't evolved to function that way optimally.
Yeah.
This is how, you know, in that particular case, why charge is important and why grounding is important, and why it's kind of interesting to think about that, you know, how are you dealing with what's going on in your body to make it something that's natural? How can you harmonize with a more natural environment, while at the same time, you know, we still want to live in our houses and go to our offices and drive our car.
So when you said, just to clarify, so when you said the static charge, specifically you were talking about a buildup of a positive charge.
It's a change in the electrostatic charge inside the body. So whether it's a positive or negative charge, it's just a non-natural charge in the body. A difficult distribution. I can't say whether it's, you know, it's positive or negative. It's just the distribution is different.
Gotcha.
When you're not grounded, the distribution of the charge.
Gotcha. Okay, sorry, it's coming through. So as you were looking into the static charge and potential impacts from a drug perspective, then that saying, okay, well, this is where it's actually at. You know, it's not about the drugs. It's actually about the charge and in your body itself.
Yeah, I mean, straight away as a scientist, I'm like, great, let's tell all the people who are on asthma drugs that they need to get outside and do grounding, you know? And then all of a sudden these asthma drugs will work better. But of course, you know, it's a drug company. They're not into grounding. They're into selling drugs. And so, you know, I kind of quickly realized, okay, if I want to do more about encouraging people to look after their own bodies, I need to move out of that environment and into something else. And that's why I then started to study nutrition and got a nutrition degree, because I thought, right, okay, this is a way that you can support your body so that, you know, if you do get an illness, that you can deal with it a bit better. You know, if you do need to take a drug, your body can process that drug a bit better, you know, if you've got a good nutritional status. And at the same time, I can teach people about grounding and, you know, all of these other things that will help support your body. Because, you know, sometimes we get ill and, you know, drugs, I'm not anti-pharmaceutical. They do have a place, you know, I think for very acute conditions. But if you can build up that resistance in your body, you need less drug, your body can process the drug better, you get better quicker. And so that's kind of my trajectory from the drug company to then studying nutrition degree. And then, of course, you kind of go down a rabbit hole with all the alternative medicines once you get into nutrition, because it never stops there, you know. Yeah. Once you've improved your nutrition, you can do the next thing. And actually, what I found with studying nutrition is there's a lot of a psychological component behind that, because most people know nutrition. Most people know that you just eat good fruit and vegetables and don't eat too many sweets. But there's a reason why people
There's the
decide
habits that
what
come with it. And
yeah.
there's the, oh, when I was a child, if I did something good, then my mother gave me this kind of a chocolate cake. There's a reward mechanism with food as well. And I think there's also a communal aspect to it as well. I mean, how often is it now, when I switched and I became a vegetarian for 9 years. And I remember when I was changing over from a complete meat and potatoes Russian eater into vegetarian food, my grandmother would say, well, what can I feed you now? So there is that communal aspect of
Yes.
food and nutrition that comes with it as well.
Yes, we're complicated creatures, aren't we, humans? There's a lot of things going on. And I think, the more layers that you peel off, certainly with regards to health, the more you can see that you can do. But you kind of come blinkered by the first steps.
Yeah.
So that's why it's like going back to light. That's why then I kind of went from nutrition and started looking at other things. And I became, like you say, involved in the more biohacking. Okay, what's the most fundamental thing you can look at? And actually, I think light is one of the most fundamental aspects of our environment. Now I've kind of looked at it, and I actually am much more into people's light diets and their food diets now.
Yeah, absolutely.
Because like you say, there is a lot of, people eat for different reasons, but I think if you can get your light environment right, then it also helps you to make better choices. You can, your ability to think about things improves so much that, the food thing then becomes more intuitive, or any of the other things.
Light ultimately fires up our mitochondria, just like our food does to some extent, but light does even much more so. And, getting light in the very early morning sunrise, Indians have been looking at this for eons. Greeks had it as well, of heliotherapy, of looking at the sun in the morning, seeing that those first rays come up. Whereas now, because we're going to bed at 11, 12, 1 in the morning, then obviously you're not going to wake up with the sunrise, and it's quite difficult. And then you also get into the idea of the different sleep types, and people saying, okay, well, I like to sleep late, I can't wake up in the morning, and that feeds into it as well.
Yeah, I'm a lion, I'm a bear, those whole things. You're right. But I think it's a habit, and it's something that you can choose. Like you say, I do that myself. I get up with the sunrise, or at the very, very least, before I do anything else, I stick my head out the window, or I just go and stand on the deck. Some way of getting that morning sunlight, because it sets your whole biology for the whole day. This is how humans work, really. They work by, we are light beings, and we are powered by light. And so you're right, to sort of see that sun, and then to kind of at least be under that kind of light for a proportion of your day, I think is hugely important.
Yeah. Now, do you find that to be the case as well, living in the UK or in latitudes where it's not always sunny and it's cloudy outside or raining outside? Do you do the same thing? Wake up in the morning and try and get out and get that natural sunlight in your eyes?
I do, because even if, we've actually got fantastic weather here in England at the moment, but it's rare. But even on a grey day, it's still very bright outside when the sun comes up, regardless of, if it's very, very overcast. It's still a whole lot brighter than it is indoors. You're still getting that signal. So yeah, I do it. It's tricky in England because, in the summer, you're having to get up mega early, and in the winter, you're having to stagger your day and getting up late, actually, because, sometimes the sun's not up till 9:30 or something. I do try and do that. And, and I have couple of little nephews, and before they say, they go and stand outside and they do their thing, and they stand on the wet grass.
Yeah,
it's a small thing you can do that's, I think, hugely beneficial.
And it's interesting to me as well, because if you look at habits, at people's habits back in the day, what did people usually do? They'd wake up in the morning, they'd go outside, they'd get their newspaper with their cup of coffee, look at the sun, just, it's that Folgers coffee cup commercial. The best part of waking up is, Folgers in your cup or whatever. And then you also have the sun, but you are going outside and you're getting that sun, you're getting that light. And now it's just go, 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 and run to the train, run to your job. And actually, even before then, you're looking at the phone. And that's the first thing. That's the first, blast of blue light that you're getting, when in reality, that's spiking your cortisol much higher than you really need it to. You need to have that. Yes, there is the cortisol awakening response that happens in the first 30 minutes upon waking, but it doesn't need to spike to the proportions that it happens when you're looking at a phone that has blue light, which is as high up as, the sun at solar noon.
That's right. And really, you need to see red straight away, because that's the kind of cue to your eye that tells you, okay, it's morning. I need to start doing morning things. I need to start producing hormones that will be used for the following evening. Like you say, if you see a blue screen before you see the red light, then your body's already going straight to noon. And you kind of then, you miss that signal, because your brain needs that signal to start the whole cascade of events or things that you need to set up for the day.
Yeah.
And it's quite interesting, people who are kind of looking at these screens, they then, not only does that diminish melatonin, but also they haven't set up their melatonin production for the next evening. Then you can't sleep, you stay up late, you look at your phone. It becomes a kind of a cycle.
Yeah. So just to rewind a little bit. So in terms of light, right, in terms of getting that morning light, you mentioned about 1, red light, and then 2, melatonin. Can you just pause and talk a little bit more about that for anyone who hasn't heard about that in the past?
Yes. So as we know, sun contains full spectrum, but at sunrise and sunset, you have a lot of red light, you can see it. Here's red. So you have a good proportion of red light at that time. And what that then is doing is it's kind of being received by your eyes, it's kind of hitting your retina, it's going to the place in your brain, the suprachiasmatic nucleus, that's kind of like the clock setter, And there's all kinds of really funky science that's come out recently to look at how that works, how you actually have these clock genes, how you kind of set off this whole cascade of events that actually starts kind of like a clock going in your head, but then it also sets off in all the different organs. So you kind of have this main clock that you have in your brain, and then it kind of coordinates all of the organs in your body too.
So getting that light first thing in the morning in through your retina, it hits the SCN, the suprachiasmatic nucleus, and then that cascades an avalanche of hormones that says, okay, we're up, we're ready to go.
Yeah,
let's hit the day. But if you don't have that light, but it's the red light that you're saying, if that doesn't hit your eyes first in the morning, then what happens?
Well, then you kind of mess up the signaling there, so you kind of have like a half signal, or your body doesn't get that message, if you like. So though you're up, like you say, you have this cortisol wake up, you're up, but maybe the cascade hasn't come down, you haven't told your gut, okay, you need to open your bowels, it's morning, we need to do this. That doesn't happen. You kind of get a toxin build up, and then your liver's kind of not quite ready to digest your breakfast because it hasn't been switched on yet.
Yeah.
Because you haven't received the signal, and so you're kind of hitting the body with all kinds of things that it needs to digest, and it's not quite ready. So it's kind of that kind of thing. It's almost like you need that trigger to tell the body, okay, this is the chain of events that's going to happen. And so that's certainly the theory. There's this whole circadian biology, it's such an exciting field, but it's really an emerging field. And we're only just beginning to discover how these things work. The Nobel Prize for Science was given to a couple of scientists who are looking at circadian biology just for working out that clock gene, because, we didn't even know that until recently. And so it's kind of like it's intuitive and it makes sense, but the science is fairly new. And so that's why it's very exciting, but, it's not, something that, I didn't learn it in any of my biology degrees, for instance, but now there's a lot of research to say, yes, you do need to have that, specifically that red light in the morning, in order to set off this whole cascade of events that go on in your body to kind of maintain your optimal health.
Nice. And melatonin, you mentioned that as well, of melatonin being produced in the morning. So I think a lot of folks will think that melatonin is something that happens in the evening, or that they need to supplement in the evening in order for them to start falling asleep. So can you talk a little bit about how melatonin starts production actually in the morning?
This is what I've read from a guy I follow. I think we have a mutual connection, Dr. Jack Cruz, and he talks about how actually melatonin, like the sleep hormone, it is a sleep hormone, and although it's released in the evening, your body starts to generate it straight away in the morning when you see that sunrise, So that is kind of what triggers off the start of that production, so that it's ready to be released in the evening. And yes, in the evening, you need to kind of wind down, and it's also that kind of red light in the evening which stimulates the release of melatonin into the bloodstream, which then enables you to have a good night's sleep. But certainly from his research, or certainly what he's putting out there, he's saying, yes, it's the morning that you actually start to produce those hormones. And it makes a lot of sense, makes a lot of sense to me. The endocrine system is a part of the whole system, and the body does things in a certain way. And of course, it's going to take its cue from the sun, because really we're mammals that have evolved under the sun for, hundreds of thousands of years.
Yeah. Yeah. And it's interesting also because going even back to the question before about what is biohacking and what does that even look, I think there is an element of this biohacking is trying to get us back to the natural rhythm of events, of the natural circadian rhythm. So in the morning, we're turning, our phones are with that red light screen over it. In
That's
the evening, people are wearing these crazy looking blue blocking glasses. And while we look a little bit like Johnny Depp in what was the movie? Los Angeles. I can't remember the name of the movie, but
is it Fear and Loathing in Las Vegas, where they're
that's it.
kind of,
Yes,
yeah,
exactly. Fear and Loathing in Las Vegas. I mean, we all look crazy wearing these blue blocking glasses. Then we see the impact on our sleep. And that's one of the biggest issues right now in health. So when people aren't getting that sleep, they're falling in the next day. They're not being able to function properly. Their work suffers, their relationships suffer. So it's one of those things where there's this chain of events of light actually impacting our sleep and sleep impacting our quality of life, and as well as I'm sure so many other things. Maybe we can get into that now of where do you see light triggering so many other things, be it sleep, be it hormones, be it all these other facets in life, be it inflammation. What are the things that because now you're studying photobiomodulation, which is specifically to do with light. So can you
yeah.
talk to us about that?
As I said, we are mammals. We have evolved underneath the sun. We're diurnal mammals. We are daytime animals, and we're covered in light receptors. Our whole body is covered in light receptors. There are a lot of different molecules and substances in and on the human body that react to light. It's one of the main cues for our biology. It's one of the main things that sets off all our enzyme systems and how we produce hormones and make energy. With regards to photobiomodulation, it's a relatively new science, I suppose. It's kind of like been since the 1960s, so not brand new. There's a fair amount of research about it, but I think it's gathering steam now because people are starting to work out the mechanism of that and how that works.
So when was it founded? What is photobiomodulation?
Well, photobiomodulation, it's a new term for a science that's been around for a while. It's maybe low-level laser therapy or cold laser therapy or light therapy. But photobiomodulation is now a more accepted term, as photo as in light, bio as in like biology in the cell, and modulation as in modulating or changing something. So it's how light changes biology, really, is what that massive word means. I mean, as you said earlier, that the Greeks and the Romans, and they've been doing that for ages, and things like heliotherapy, and, even for the last, TB epidemics and things, people have been used to having sun therapy. But I think photobiomodulation is usually credited to starting around about the end of the 1960s. And there was a chap called Dr. Meister, who was looking at rodents to see whether lasers I think he was looking to see if they would induce cancers, actually. Don't quote me on it. He was doing something with rodents and ruby lasers. And what he found was when he cut the rodents with the lasers, actually the ones who he'd used the lasers on, their hair grew back quicker than the other animals. And so this was a surprise because he was really looking to see if the laser was harmful. And what he found was, in actual fact, it encouraged hair growth. And then from there, this science kind of evolved to look at, okay, how could you maybe use these red lasers to exert some kind of health benefit? And originally it was lasers because LED technology is fairly new and it was not as good as it is today. But now we have the advent of very efficient LEDs, and some people say it's actually even better than laser. So the term photobiomodulation replaces all of those other cold laser, low-level laser terms.
So this is something that it's using light as a healer, is using light to, in his case with the rats, initially it was for baldness and curing hair growth back. But now
he thought it was going to do them harm originally. I think he was looking to see whether lasers caused cancer in animals.
Right.
And it didn't cause cancer. And in fact, it made their incisions grow back quicker. So it was kind of because it is a bit counterintuitive that red light is going to heal you. It's not, it seems a little bit space age that you could get like a laser and you can make hair grow back just by shining a laser. But that is what happened. And that's kind of what happens with red light. It is a very healing modality.
So do we know the mechanisms of what photobiomodulation actually does to the body in order to stimulate this hair growth or whatever other benefits happen?
There is a lot of research on it, and there are some theories that seem to be more widely accepted, and there are some theories that are currently still being elucidated because, like I say, it's a fairly new science and not huge budgets for looking at these kinds of technologies, although that is getting bigger. One of the main ways that it's thought to work is by the mitochondria being accepted by an enzyme in the mitochondria. That seems to be the most researched mechanism at the moment. So the light penetrates into the body, and the degree that it penetrates depends on the wavelength of the light. So red light, which is around 600 to 700 nanometers, say, just for simplicity, kind of doesn't penetrate very deeply into the body. It kind of is surface level. And then near infrared light, which is usually bracketed together with red light, that penetrates a little bit deeper, about 10 centimeters. So you have these ranges of red light, but it enters the body at various depths and is received by the mitochondria, specifically an enzyme in the mitochondrial membrane wall, which is a particular enzyme called cytochrome C oxidase. And this enzyme is part of the whole respiratory chain, which, you know, it's kind of going back to that thing in biology lessons, you know, the Krebs cycle and oxidative phosphorylation, you know, all of those things, but in very simple terms, it's just how the cell makes energy. It goes into the electron transport chain, and the photonic energy kind of acts as a electron donor into that chain, and so then you have this production of ATP, which is the energy molecule. So one of the main ways that this technology is working is giving the body additional energy. So for a start there, you've instantly got a mechanism that kind of covers a lot of things in biology, because if you've got more energy, you can do a lot more. You can do more healing, you can grow more hair, you can make more cells. In addition to that, you have a release of nitric oxide when you have this reaction. And nitric oxide is another important molecule in the body. And one of the main things that from point of view of photobiomodulation is it helps with increasing blood flow. So then you have a combination of more energy and more blood flow, so you can get more nutrients to the site, you can take away more waste. So not only do you've got more energy, but you have this kind of way of helping the cell to become more efficient.
So it sounds like a silver bullet. A little bit.
It's amazing when you kind of look at it, oh my goodness, you know, why is not everybody talking about this? Because it's the most amazing thing, you know. It is a little bit like photosynthesizing. It's like getting energy from light, you know, which we thought was the domain of plants only, but no, it does seem to be something that animals do too.
Yeah, I mean, it is interesting as well if you look at how a mitochondria looks like versus a chloroplast, which is in a cell. It's quite similar. Right. So while there was some quote I remember of, you know, we're just complicated plants that we just, yes, we're able to move around, but ultimately fundamentally, we need light, we need water, and we need magnetism. So we need we need grounding to actually be able to be net negative and not have inflammation in our bodies. So it's interesting to me that photobiomodulation, yes, while it's a new science in that we can test it and we can see specific things that is beneficial, to some extent, is it accurate to say that photobiomodulation has been around not at the laser level or not specifically at the red and near infrared standpoint, but the idea that light as a healer at least has been around for decades? Is that an accurate statement?
From a technology point of view?
From light, kind of the spectrum of light, can we say that light has always been a healer and that now because we're able to look at the red and near infrared, we can kind of laser in those elements, that spectrum of light specifically to give more energy into our bodies? Is that fair?
Yes, I think so. Within photobiomodulation, it isn't just the red spectrum. I mean, for different things have different uses. I read an interesting paper the other day, green light for migraines, you know, blue light for acne. You know, there are different applications. Red light therapy tends to be more healing because it's in a part of the spectrum where the wavelengths are not so energetic. You know, the effects are gentler, if you like. If you think about, if you go the other way down the spectrum, you get to UV, and then that's what they use to like kill bacteria. You know, you can kind of disinfect things with UV because it's a more powerful form of light. But as you come up the spectrum, there certainly seems to be applications for blue and green, you know.
Yeah, I had heard that folks who focus on skin, they are starting to look at blue light specifically for acne and skin healing.
Yes, if you have some kind of, you know, bacterial infection in the skin or something like that, then they're now having like blue light may be really beneficial in that. And actually, I was kind of looking at some, you have the women's group and women's biohacking with kind of that slant. And I was looking at some research today, and for things like candida, they're now finding that, you can have blue light, for example, seems to get rid of that. So you could have that as a treatment for candida infections. Non-drug, and it works, because things down that end of the spectrum, because it's more powerful, it has an effect on like the cell walls of these prokaryotes or, the yeast. And so you can have these wonderful applications of light, which is cool because, you're in harmony with the body, you're not putting toxins in the body, and you're kind of using it's the sun, the sun contains all of these spectrums, the sun contains all of these wavelengths. You're getting that by being outside. We're just finding a way to hack it, to bring it in and to concentrate it and target it.
Yeah. So it's almost saying that we've always had the sun as a healer, but now we're able to parse out the different spectrums of light into the specific areas that we need the most. So if it's blue light for acne, or green light for migraines, or red light or near infrared specifically for, baldness, or for inflammation or skin problems as well.
That's right.
Fascinating.
Yeah, that's where we're at with the technology, I think. Not only can we kind of separate out the wavelengths, but we can also kind of change the power, the intensity, the dose, so that you can get a very concentrated dose of, of sunlight, almost targeted to specific areas.
So then with photobiomodulation, we aren't specifically just talking red or near infrared. It's how can we use any light? So it could be red light, near infrared, green, or blue light. Any version of that can be classified as photobiomodulation.
That's right. So that's why usually we say red light therapy, just to make that distinction that we're talking about the red and near infrared range when we're talking about red light therapy. Right. It's kind of an umbrella term of photobiomodulation, but a subset of that is the red light, because that's particularly beneficial, and it's easy and it's safe. You can have that in lots of different devices without, there are things, with the UV, that you don't want to use that too much. We all know how damaging UV can be. Like I say, we use it for disinfecting areas. So yeah, the red light tends to be its own category.
And so in terms of red light versus near infrared light, can you just talk us through what are the different applications? I think you originally mentioned red light is for something that's topical. It doesn't penetrate the skin that much, but near infrared penetrates it more, correct?
That's right. So near infrared light tends to be used for deeper issues, certainly things like joints, because if you want to get into a joint, you need near infrared. Otherwise, the red light is going to be fairly superficial. For the transcranial, to stimulate the brain, usually people use near infrared because you have to get into the skull. There's a debate about how far in you're getting to the brain actually, and whether or not some of the effects are maybe surface effects. They have a similar receptor, both the cytochrome C absorbs red and near infrared. So perhaps it's a similar mechanism, although again, nobody's entirely sure how that works because there are other things that absorb red and near infrared. Water, for example, is also a chromophore, and that's something that's being explored to see, okay, how does charging water have an effect in the body? And that tends to be mainly near infrared because it's higher up the spectrum that you get water having an absorption peak. It kind of peaks over 900 nanometers, so that's kind of well and truly in the near infrared. So it could be that they have different effects in the body, but mainly it's widely thought that they have a similar mechanism, but they just have different penetration depths.
Got it. And so if we're able to impact water in our body, and we're, I don't know what percent body, but fairly large percentage of us is water weight. What does that actually mean from a healing perspective? If you're able to modulate the water that's in our body, does that impact inflammation, or what do we know what that could do?
Well, water research is really interesting. Yeah, that's a fascinating topic. And if you've kind of looked at Jerry Pollack's work, which is this professor who's looked at water having 4 phases. So you're familiar with a solid, liquid and a gas, but he's now saying that there is another phase of water and it's a gel phase. And this is water that has been charged. And the way that he discovered it was that he had a student in a lab that kind of left a light going overnight. And then what they found, it influenced their experiments to the extent that they kind of had this layer of like gel-like structured water. And from there has come, a whole fascinating kind of chain of research looking at structured water in the body. Because if you shine light onto a hydrophilic surface that's kind of like a water-liking surface in the body, like a membrane, you're actually able to charge water to the extent you kind of push out the protons and you're left with this kind of negative water layer. It's a bit like ice. You know, ice forms like a lattice, but because you've pushed the protons out, it's slippery. So you have this like slippery layer of water that's next to things that are charged in the body, like proteins and membranes. And so the body works on this kind of principle of charge. And this is how proteins fold and how all kinds of enzymes work. So if you then alter this kind of charge by changing the water around it, then you have profound effects potentially on the body. So things like proteins folding normally and having like linings of your blood vessels to be more slippery so that the blood, you know, is more efficient and easier to flow down. Or even like in the mitochondria, we talked about the mitochondria. If you think about the production of ATP is from this amazing molecule, which is the ATPase, that kind of spins like it actually spins like a little rotor. So if you imagine this little rotor spinning and making energy, if it's got this kind of slippery water all around it, it's more efficient.
It can spin faster.
Spins faster, more energy. So the effect on water is potentially profound. You know, you have this effect of charging water. And people are looking at it. But like I say, at the moment, it's one of the things that's not so widely talked about with photobiomodulation, but certainly a lot of people are starting to look at, okay, is it water actually that's having these amazing biological effects? You know, is it this way that we're changing the charge on water that's having some of these major healing effects?
Mm-hmm. And again, you mentioned for the water specifically, that's near infrared versus red.
Yes, it's near infrared and it's higher up. So it's above 900 because you can kind of look at a peak. You can look to see where it kind of goes up and then it peaks. So it probably does absorb maybe a little bit in the red and then a bit in the near infrared, but it peaks up around about 900 nanometers, which is near infrared. But still, you know, you're kind of on the slope there where it's still absorbing in the red range.
Yeah.
You know, we don't know how much does it need to absorb for it to have a biological effect. You know, that's still not been researched. It could be, you know, you don't need to have a huge amount of light to have an effect, in which case, you know, even red light could have an effect.
Now, you also mentioned before about the impact on the blood. Can you talk a little bit more about that and what that looks like?
Well, the blood contains all kinds of interesting things too. Heme, actually, it's a chromophore. It's sensitive to light. So, and kind of anything with that kind of ring structure will resonate with light. But there's some really very interesting research that was published last year. I think it was even last year that found there are free floating mitochondria also in the blood. You know, the blood is very interesting, and the blood too, you know, has a lot of light receiving molecules. And so, you know, even if you're just doing something surface level, you can be having a huge effect on the blood, and then that will transfer, you know, that kind of increased efficiency and energy to everywhere else in the body, which is another thing that's kind of being researched now more in photobiomodulation, is the systemic effect. You know, you have this local effect, you know, if you want to target a joint or the brain or whatever you're trying to do, but they're now finding, you know, there's a huge systemic effect of using red light in that wherever you put it on the body, either via the blood or via the nervous system or by the fascia system, you know, there are a lot of systems that are totally interconnected in the body. Just by shining light on the body or on the skin or into the blood, you can have a profound effect on the body as a whole.
If we're using one of these devices and putting it on, you know, my knee, for example, right now is really in pain. So if I put it on my knee, and while that'll have localized effect, it could also then be impacting the rest of my body and rebalancing the rest of my body as well.
Yes, because the blood that's in your knee now will later on be in your heart and will later on be in your brain and be, you know, the blood is going everywhere. And so if you are then charging those mitochondria, there's also, you know, mitochondria also travel to where they're needed too, which is an interesting thing. You know, we think of these things as being like stuck in the cell, but actually it seems like they're not so much. You know, they're mobile, you know, they can go to different places, and your body kind of has its own intelligence. You know, your knee may be really sore, but maybe you have a problem that you're not even aware of. And your body is, of course, and will send, you know, the energy to where it's needed. So again, it's something that we don't think about. You know, we kind of have our own idea of what we need to do to heal, but inside we have all these systems, and
Yeah, I love that you say that, and as a tangent a little bit, but I've personally just had a lot of kind of pains, aches and pains on my left side. And what was told to me was interesting was that your left side is your feminine side. So your left
Mhm.
side is, Dash, are you working on your feminine energy to some extent? Have you actually tapped into that? Or are you so in the moment, so focused on go, 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 achieve, 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 get all this stuff done that you're perhaps lacking in that area, or not, not fully feeling into it. And so I don't know if there's truth to it, but it's something that's been brought to my mind that's kind of interesting to think about, that, my ankle, my knee, my shoulder, my everything is all on the left side.
Yeah, your body speaks your mind kind of thing.
Yeah. Yeah, exactly. Yeah. So in terms of specifically for women's health, if we can just shift to that and the ailments that it seems that the photobiomodulation has been researched in, I think, I'll just list off a couple of thoughts and then you can let us know what you think it is. So collagen, Alzheimer's, Parkinson's, skin health, period pain, pregnancy. Those are the kind of 6 that come to mind from a women's health perspective. I can list you through them as well. But initial thoughts for first, women's health research. What, if anything, has been done with light?
Yes. Yeah, I had a little Google around today, and also I've been kind of keeping my eye open for research. And I actually was doing a summit the other week where I kind of got to speak to a lot of the researchers, and I've asked them all, I've emailed them all, is there any gender differences? What have you found? And no, there is not a great deal of research on photobiomodulation looking specifically at gender differences. Although some of the things that you just brought up now, like particularly Alzheimer's, they are actually looking at different gender animal models, specifically because there are differences in the responses of the different genders to things like that. So it seems like memory loss and things, they use a female mouse model for that because it's more of a female trait in dementia. And when you kind of look into it a bit, it's, obviously there are differences between the genders. We're not just small men. And the main difference is in the endocrine system, of course, you have this different level of hormones. And it does seem that, certain female hormones may convey an advantage or a disadvantage in certain cases, in certain illnesses. And if you think about, photobiomodulation is working kind of at the fundamental level of giving the cell enough energy, but it also has knock-on effects on all of these different systems like the endocrine system. So you may expect that there would be some differences, for example, things like Alzheimer's. And at the moment, there aren't different treatment protocols based on that coming out, but I assume that there may be soon, because things like dementia, of course, it depends also on things like stress. And of course, the difference in the stress response, that is something that has been documented now quite well, the difference between the male and the female stress response and the different chemicals that are involved and the different kind of psychological profiles and why that might happen. So I think for things like Alzheimer's, dementia, where there is a definite gender difference, that we may start to see some different protocols with red light. But at the moment, I think we're still at such an early stage of just trying to get light into the brain somehow that at the moment, if you can just get light into the brain and see a difference, that's a good result at the moment.
So has there been research done on Alzheimer's and photobiomodulation in general? There has been, yes.
There has. There's some very interesting research on transcranial photobiomodulation, which is using, light specifically over the head. There's a good summit that's happening right now called the Brain and Transcranial Photobiomodulation Summit, where all of the researchers are kind of giving presentations, and it's quite cool. You can watch it for free. However, it's still, there's still not very much research that's published. A lot of it is fairly small scale. Or
now, are they finding this for people who already have Alzheimer's or people who have indications of Alzheimer's and trying to make it such that it doesn't progress further? So is this something where they're catching it ahead of time or trying to help while somebody is already has Alzheimer's?
At the moment, the main research is mouse model. It's using a mouse model of Alzheimer's and Parkinson's too, and seeing how that has an effect. And that's why I brought up the gender difference in the mice, because they do tend to use more, for Parkinson's, they use a male mouse line, and for Alzheimer's, they tend to use a female mouse line, because you have these more pronounced differences in females in that you have like kind of things that's easy for them to monitor with things like mice, like memory loss, for example, seems to be more pronounced in females. Mm-hmm. And I'm wondering if that's because of the stress response. You know, you have this different way that the brain processes stress, and so the different systems are affected slightly differently in males and females. So there's a lot of mouse model research. There's a lot of research that's even more experimental, looking at cells. Okay, what happens to the plaques and the tangles of Alzheimer's when you shine light into the cells? So we're kind of at that level where we're still at the animal studies level. However, there are a few studies that have been done. Margaret Naser has looked at some stuff with things like TBI, and I think she's done Parkinson's too. I was involved last year in a study looking at Parkinson's disease, and they've got a few subjects still to recruit to make that study complete, but that should be published next year. So there is data coming out. But at the moment, to answer your question, it's more looking at people who have the illness, if they can either stop progression or even reverse it. Certainly some of the Parkinson's, you know, they're actually seeing a reversal of some of the symptoms, which is super cool. You know, I don't know if you saw that thing where in Tasmania, they did the buckets on the head with light.
No, not yet.
In Tasmania, they kind of got, you know, it went viral because someone just, you know, is a total biohack. They decided, okay, light's going to work on mice. Let's put it into buckets and put it onto people's heads who've got Parkinson's. And they got such brilliant results that they've now been funded for a study because, yeah, things like memory and anxiety and mood, they found a positive result just from doing those kind of fairly...
What was the duration for that then? Is that something that we can do at home and help ourselves as well? Is that 20 minutes a day? Is that 10 minutes a day? Or is...
Oh, yeah. We can definitely start to... I mean, I'm totally into having a good brain. You know, this is one of my main goals in all my biohacks is how do I keep my brain going for as long as I can? You know, I'm getting older. How do I, you know, I don't want to go into cognitive decline. So this is what my main use of the light. And we spoke before about systemic effects. The device I have, which is like a small portable device, the Recharge Flex Beam device, I put it across my gut with the intention of charging my brain. I mean, the microbiome is another massive, interesting topic that's now becoming, people are recognizing the importance of the microbiome, specifically for brain disorders. If you can get a nice environment for your microbiome, you're helping your brain.
Yeah.
So I definitely do that. But also you've got the vagus nerve there, you've got blood flow going up to your brain. So I do that. And I also have pads which I use transcranially with near infrared light, because there is evidence that if you're not getting into the brain, which it looks like you are, at least you're getting all of the blood supply around the head.
Now, have you seen a difference with that by doing so? Or is this something where you haven't noticed a difference, but you are doing so knowing that something's happened underneath the surface?
At the moment, I've just started out my own kind of N=1 trial on this, because it's something I've been doing a while, but because I travel so much, you know, it's kind of, I never have like a controlled environment. Now maybe this kind of lockdown thing is giving me that, because everything all of a sudden, you know, is controlled. You know, I'm eating the same things, I'm seeing the same people, you know, I'm going to the same places. So I've just started to do an N=1 experiment, and I'm looking to do specific tasks like writing notes on the presentation, and then maybe like recalling some of the things, to see whether or not that's affected by things that I do, which is I do 10 or 20 minutes across my gut with near infrared light.
Can I raise my hand to be part of your study as well?
Yeah.
Because I will do that with you. For me, I'm fascinated in the brain, in part because of my own concussions and in general. I mean, I was studying neuroscience. So for me, the idea that, yes, I don't want my brain to decline at all. And there's already, you know, there's nootropics that you can be taking. There's vitamins I can take. There's omega-3, you know, there's so many different supplements. But if what the studies are showing and what could potentially be the case, where light is such a healer and we are giving energy into our cells, and we could potentially be changing how our brain functions. And for 10 minutes a day, yeah, sign me up. I'm there.
Yeah.
Okay,
yeah.
That's the thing.
Cool. And there's things you can do, like test yourself, you know, like even things like mental arithmetic, you know, or like doing a Sudoku or something like that, where you can kind of see, okay, how is this going? And then not use the light for a while. You know, this is kind of the essence of biohacking. There are things you can do on a phone that actually do track your problem solving and all of that. I just kind of have a resistance to looking at a phone more than I have to. But, you know, if you were into that, there are kind of programs that look at, okay, this is testing your problem solving, this is testing how you can kind of arrange shapes in a 3D space and all of that. I'm finding, okay, can I do mental arithmetic quickly? Can I to the notes? Do I feel like I'm absorbing what I'm reading, you know?
Yes, biohacking is the quantitative, but there's also the qualitative, right? There's the, do I have brain fog? Do I remember things all as quickly, as sharply as I would if I had a cup of coffee? I mean, we can tell the difference when we have a cup of coffee or when we take a nootropic, you know, so maybe it's an element of that, of, all right, over time, yes, maybe it won't be as instantaneous and as black and white as taking, you know, a nicotine spray or coffee, but maybe after 2 weeks of use or a certain period of use, then we'll be able to see it. That's interesting.
It was interesting on the Parkinson's, the Buckethead Parkinson's study, they found that the Parkinson's patients were slow to appreciate their gains, but it was the carers and the doctors that were reporting that they were changed, you know, so that was interesting as well, to get a kind of external feedback.
If we start doing the kind of N of 1 studies, seeing what other people around us are saying, actually, yeah, you do remember things or more frequently, or you're remembering to get things from the grocery store.
Yeah, that's right. Yeah.
Interesting. So in terms of some of the other things that I think other women would be interested about with respect to what photobiomodulation can do, skin health. I know you mentioned there was blue light that can potentially be used for skin health. I've also seen a lot of these influencers and folks online using red light, saying there's such a benefit to either collagen production or just wrinkles or anything like that. Are you seeing that to be true?
I mean, yeah, the beauty industry is huge, and you know, they've kind of really taken to red light because it works and because, you know, it's inexpensive and you don't have to have things injected into your face. I mean, the beauty industry is huge because, I mean, we spoke about water, so, you know, collagen is just like this helical protein that's hydrated, you know, it's surrounded by water. So the more water you have around it, the more plumped up it's going to be, you know, the kind of nicer, you know, less wrinkles you're going to have on your face. Yeah. But also, you know, the red light does stimulate collagen production and elastin, which is also what kind of, you know,
keeps your fat, you know, keeps it tight.
Keeps your base tight, yes. So there's all those things. So yes. And things, you know, like cellulite, you know, that kind of where you have these like collagen gets all bunched up and the elastin gets all bunched up, and near infrared and red light seems to have an effect on that, where you know, that becomes smoothed out. So certainly for things like that, for aesthetics, yes, it's used for collagen and elastin, but also collagen, you know, it's not just a beauty thing, you know, collagen is like your structure, your internal structure, you know, it's your tensegrity network, you know, it's how your fascia is all made from collagen. So if you tighten up your collagen, you know, you don't just look good, you also, you know, you have this structure in your body, which is, it's potentially a communication system too. I don't know if you've heard about the living matrix, which was a guy called Jim Oshman proposed this theory called the living matrix. It was probably about 20 years ago, but it's now, his thing was the living matrix, which is about this, you know, we're kind of in this like sac inside our body, you know, and it's made from collagen fibers mainly. And from a fascia point of view, you know, if you pull something here, because we are in these kind of fascia suits, you know, that's why you can get like a referred pain or something, because you can pull something. Yeah. And so having kind of improving the integrity of your collagen network is much more than just an aesthetic thing. The fascia system is probably crucial for communication in the body. It kind of acts like a crystalline structure, you know, like a living crystal, you know, you can have this kind of communication through the fascia networks, and maybe even, you know, light communication. I know we're maybe getting a little bit woo-woo now, but if you think about biophotonic emission, you could maybe the fascia system could be a way that communication works over the body. You have this like instant communication through this system. So I think, yeah, having good collagen and increasing your collagen and your elastin production is a good thing, not necessarily just for wrinkles, but for your whole system.
So it's, I mean, it's the same thing, right? You start with one little thing thinking that it's just for a superficial benefit, but then it ends up reverberating into everything else. So you start out with saying, okay, I want to look good from a skin perspective, but then it's saying, well, everything is connected. So when you heal your gut, you end up healing your skin. When you focus on your skin, you're going to end up getting to the gut, and from the gut, then you're going to get to the brain. So it's, you start on one lever and then you start pulling everything else around it too.
But that's why I love red light therapy, because it's something that you're doing to maybe, heal something. But by healing that one thing, you're actually coming out more healthy than when you went in. But with a drug, you're healing, potentially you're stopping that one system, but then you're damaging your liver and toxic, so it's kind of the other way. You kind of take a little bit of damage when you do that kind of therapy, but with red light therapy, you're actually strengthening your system at the same time as providing that symptom relief. So you kind of come out better, it's kind of whatever, like you say, you maybe want to get rid of your wrinkles, or you want to help your dodgy knee, but by doing that, you're actually strengthening your whole system.
Makes sense why not many people know about it, because it is, to some extent, it is a silver bullet, right? Now, it's not maybe instantaneous, and it's not going to be something that's going to fix everything, but because there are so many reverberating effects, then imagine how many industries it could also impact in a way that those industries don't want to be impacted by, Understandably, it makes sense that a lot of research hasn't necessarily been done, because you can't make research is inherently reductionist. So inherently you have to stop, focus in on one little thing, but in reality, red light is helping the entire system. So how can you be reductionist?
That's right. It's difficult to research, but also we're kind of at an early stage in the technology where it depends on the dose and the wavelength and the frequency. There are a lot of variables in red light therapy, and so there's kind of not a consensus on that. Which power for which condition, which fluence, which irradiance, how long, what kind of LEDs. There are a lot of moving parts, and I think that's one of the kind of blocks at the moment, is we kind of need more research to kind of find, okay, this seems to be a good wavelength for this condition, or this is a good general one, or this power for this time seems to be optimal.
Now, typically the times that the research has been done for, what does that look like? Is that 20 minutes or 10 minutes, like you said, you do for yourself?
Yeah, so like I say, the research, because the research there's a lot of animal data there, it's difficult to extrapolate that to humans. And then the human data that there is there, it's not, every researcher's kind of picked a different combination of times and doses. But generally, for a high power device, so the device I have is a fairly high power device, 10 minutes is a good session, a good daily session. So for this particular device, we tend to recommend between 10 and 30 minutes a day is enough. And kind of counter to how you might think, actually, the sicker you are, the less you need.
Why so?
Because your mitochondria are normally, if you're ill, your mitochondria are normally suboptimal, or you have issues there. If you stimulate, imagine you're getting the system working, you produce waste products. And if your system is sluggish and you're not detoxifying, you can find that you're overloaded with waste, and it's a bit counterproductive. So for people who are very compromised, 10 minutes every other day is probably enough. But, people who are, at the peak of their health, they can probably handle 40 minutes every day. So it's kind of a thing where you have to make a judgment. But for most people, 10 to 20 minutes is really all you need.
Nice. Now, you mentioned a high power device. So what does that look like compared to the other? Because there's numerous ones on the market. And I think there's ones that you can find a light bulb and buy it at a Home Depot or on Amazon. And then you go the entire, full gamut to others that I've seen, panels, very large panels that end up being a couple of $1,000s. One, what is the power component to it? And then two, what do you see as the main differentiator for that price range difference?
Yes, there are a lot of different products on the market, and you can have little handheld lasers, you can have big panels and devices. So the big panels, they cover a big surface area, and usually dose is calculated for your surface area that you're exposed to. The panels also, the further you are from the light, the less of the light you receive. It kind of falls off quite a lot. So, it's difficult to work out the power because it totally depends on your distance from the device.
So if you're that close versus if you're that far away, there's quite a big of a difference, even though the distance isn't changed that much.
That's right. So, but normally the big panels I mean, I think you're looking at a dose of something around, let's think, like 30 joules per centimetre squared, something like that, because they're big and you're kind of getting your whole body. So they're like kind of like showers, you know, you're kind of showering yourself with this light energy, which is cool. You know, so if you've got a fairly reasonable one of those and you stand up, you're kind of getting a whole body experience, and you're hitting a lot of the receptors on the body. But again, you know, you do want a reputable company. You know, you want one that's, you know, shielded from EMFs, because you don't want to kind of expose yourself to too much non-native EMF while you're standing there naked in front of it, because it's counterproductive. So things, you know, you don't want to just buy a cheap one from Amazon, really, because that may be an issue.
Yeah, because you could be getting the benefit of the red light, but then you're getting the detriment of the EMF. So net, you might actually be net negative, you know.
You may be net negative, and in fact, the light may not be putting off enough power to do anything, so it might just be totally negative. But what I would say is, if you're looking at the panels, you need a high power one, and you know, you're going to be standing there maybe a little bit longer than you would for something more targeted like a laser, or like the flex beam device. Because if you can have the device where it's actually in contact with the skin, then you know you're getting the full dose. And also, the more you can shape it to the body, the more you know you're getting the dose, because light travels in a straight line, and so you really need to bend the device around yourself, because the light's not going to bend to you. You know, so if you're standing in front of a flat panel, you know, a lot of that light gets scattered and deflected, because, you know, the angle has to be right. You know, imagine if you're firing an arrow into something, you know, goes off the side, it's just going to bounce off. That's what light's like. The panels are cool. They give you like a good overall body dose, but the lasers and the ones like the flex beam that you actually put flat to your body and you contour around, then you know you're getting like a dose targeted to where you need it. And you also want to make sure you're getting one that's got medical grade LEDs or lasers, because, you know, some of you say like a light bulb or like a reversing light on a car, it's also putting out a lot of toxic metals, and if they're not shielded properly, you're getting a lot of different electromagnetic waves. So you need one that's got medical grade lasers, you need one that's got a fairly high dose, and it's better if you have one that's kind of, if you're looking to do something targeted, have it flush to your skin. And something that will contour to your body.
So this is one of those things where it's interesting, because yes, it's worth it to spend the money to actually have a proper device. So it seems like it's a fairly large expense, but the beauty of it is that also, and I feel like I'm being a salesperson, but the beauty of it is also that you can then use it for so many different reasons. You can use it for skin health. You can use it for joint pain. You can use, I mean, like we were saying, not that it's a panacea, but it is going to help a number of different ailments that not only you have, but maybe your family members have. So this is one of those things where you can pass it around your family and kind of spread that cost around as well, and spread that benefit around.
And sometimes it's not that, I mean, like the panels or this flex beam one, you know, you can get them for like $500, and then, you know, initially it's a big outlay, but, you know, if you're going to a chiropractor or if you're doing all different things, you know, that soon adds up too. So, you know, you kind of weigh up, but you don't need to spend thousands and thousands and thousands on these things. You know, you can get them for fairly reasonably.
Yeah. And I have to say, just as a story, kind of anecdotally, but so I got one of these devices, medical grade, and I had my mom who had some dental work done. I had her use it. Now it had a little panel, so it was a wrist device, but then you can move it around, right? So I had a panel that you could specifically target. And I said, okay, 3 times a day for 30 minutes. So it was quite high. Now, because it was small, they had a setting of 30 minutes each. Now she would just put it onto her cheek, and she went back to her dentist the next week. He said he had never seen such healing ever in his life. It was that quick. He's like, whatever that is, I need to order it. I need to order it for my patients, because the stitches were able to come out. Everything was, you know, it was just, the healing time was tremendously quickened. So fine. While the expense was a little high in the beginning, you know, she now swears by it. Every time she has something, she's like, okay, red light, I'm going to put the red light out. You know, it's kind of one of those ideas as well. Do you have one of the flex beam devices with you? Do you mind showing us?
Yes, I have one.
Not that this is a product demo, but I think it's interesting to see how the technology is changing.
Yeah, so the cool thing, let's see, is it on?
Nice. Okay.
I'm not going to shine it. I'm not going to put it too bright, because it's actually quite bright, so I don't want to blast you with it.
Thank you.
You can see there's quite a big output. The cool thing about this device is that it contours to you, you know. So you have like 3 panels, and you have like red lights and then you have near infrared lights. So you can actually change the ratio of that. So if you want to just have it red, if you're trying to do something that's more surface level, then you can put it on the first setting. You can have a mixture, or you can put it mainly on the near infrared. But like I say, the coolest thing about it is that you have this kind of convergent beam effect. Because if you imagine, you know, anything that's flat, you're just going to get the light that's coming off. But this, you're getting like the convergent of those three beams together.
So yeah, if they're all coming together at the same
That's right.
Yep.
If you can really target a knee, or you can really target a shoulder or something like that. Like you say, I kind of wear it across my abdomen because that's kind of what I'm trying to do. And it's lovely for that because it's, you know, it's just flush and you could put it on. The other cool thing is because it's got a strap, you're not standing naked in your bedroom for half an hour. You know, you can just be doing your work or doing your workout or doing your cooking or whatever and just have it strapped on. And you're not taking up time from your day. You know, you can kind of stack. That's the trendy thing to say, isn't it? You can stack your biohacks.
Yeah, exactly. Because that's one of my challenges right now is with the panel that I've got. I have to spend time in the day standing in front of it. Time is money, right? I don't want to be standing in front of that. I want to go do things.
It's a kind of a block to doing it, isn't it? If you know that you have to spend time doing something, then, you know, it's kind of a block. I mean, I sent you a picture actually today of me getting ready to talk to you, and because I have other pads, but I don't use them as much as this because I have to get it out, plug it in and lay down and do the whole thing. But I did it today just for the shot of me like there.
Oh, nice. I'll have to see it. I didn't see it yet.
I put it on Instagram. But the good thing is, you know, I do this a lot more often because I can just put it here and then I'm still working or still doing whatever. And it's not something else that I have to think about doing and take the time.
Right.
I think that's a big block for some people. You know, it means that you use it less and less. And certainly if you're kind of not working on something or if you're getting well, you know, I mean, I think if you're ill, then the incentive is there to use it all the time. If you're not, then you do things that are convenient.
Sure.
And so this is very convenient.
Sure. Now, from an EMF perspective, have you guys measured it? I assume you have.
Yes, we've measured it. And actually the guy who developed this, super cool guy called Arian, he's totally obsessed with EMFs. You know, that's kind of his thing. So he's designed it. It's kind of all totally sealed. And the good thing about it is because it's battery operated, you're not getting any of the signal from the mains, which is one of the main things with any of the devices that you use when they're plugged in. You know, if you've got a meter, I don't know if you're geeky enough to carry a meter around. I've got a meter I carry.
Yeah, I do. Yeah. I'm one of those people that goes onto the flights and I show the flight attendants, listen, this is where your router is. This is where the Wi-Fi is coming from. I will not be sitting here. And they look at me like, what's going on with you? But, you know, it's one of those things that once you know these things and once you're aware of how they're impacting your health, you just start going down the crazy loophole.
You do. And you become that crazy person who goes to stay at someone's house. It's like, no, I'm not sleeping next to that phone. And if you use your device on this, you can see, or even like on a panel or anything, you can see that you get a lot more dirty electricity or e-smog or non-native EMF when something's in the mains. And it changes between countries, you know, the oscillations change. You know, America has a different system to the UK. So you get like these different oscillations, like 60 or 40 hertz. So you don't get that with these devices that are lithium battery operated.
Nice. I'll have to put my meter out and
test it.
I will.
See, compare it to your other little device and see.
Yeah, that'd be great. That was great. Nice. Anything else about the Flex Beam? We're going to release this podcast right around when you are launching or you're starting a Kickstarter.
Yeah, it's a company that's just starting up. It's based in Thailand. Super cool. Everybody there is super cool. They've got skateboard ramps indoors and bulletproof coffee, you know, the whole thing. And what I like about them is that they're trying, you know, they want to make a device that's affordable. So it's under $500 for the reason, you know, that it shouldn't be an elitist thing to do. You know, you should be able to have access to it. So it's a kind of a nice price point that allows them to have a really quality device and also allows people to within the range of something that most people can buy. Yeah, that's the cool thing about it. I mean, this is kind of like the first product in their range. They're also looking at a brain device and maybe some boots you can wear, and you know, there's all different things in the pipeline. Yeah, it's a good company to look out for. You know, they've got a lot of things right, and you know, this is a really cool device, and I've been trying it with bodybuilders and with doctors and all different people, and it's versatile enough that, you know, you can kind of use it for different things. You know, like performance people love it because they can wear it while they're training, but also doctors like it because they can kind of integrate it into what they're doing in clinics and things.
Have you worked with pregnant patients or folks who are pregnant? Is that something that you would recommend not using, or?
Well, there's not really enough data to recommend red light with pregnancy. You know, it's one of those things where companies can't say to use it while pregnant
Sure.
because there really just isn't enough data yet to say that. And normally for any kind of technology, you know, there's the caveat, do not use when pregnant, you know,
Sure.
mainly for insurance reasons. But so no, for that reason, we haven't and we don't recommend it.
I wonder also for women who are experiencing PMS or any menstrual cramps or things like that, if this could help.
Yes. We have done a study. There is a little clinic in Thailand where we kind of do some informal studies and things like menstrual cramps. Yeah, it's really good for that. It's kind of a little bit warm, so it's a bit comforting, but then you kind of have this anti-inflammatory and, you know, pain reduction. So for things like that, it's super cool. And it's not, you know, it kind of sits right there nicely.
Yeah. So is that something that you would recommend doing the week before menstruation or on kind of when you're menstruating, and saying it's almost like a hot water bottle that you
It's
can
not
put?
much like a pain relief device in that sense, that I would use it then. Although I was looking at some studies today with things like polycystic ovary syndrome.
PCOS.
And so there is some evidence that because it supports the endocrine system, because red light supports the endocrine system, that for things like polycystic ovary syndrome, that it would be a good thing to kind of integrate into some kind of program for that. Anything where you kind of, looking at hormone imbalance. And, you know, not just a hormone imbalance, you know, to help with hormones. I mean, things like sex drive, you know, and things like having a good sex life. I mean, if you look at red light, you know, if you kind of Google it, you'll come up with Ben Greenfield talking about, you know, how he uses it to increase testosterone, you know.
Right.
But it's not just men who produce testosterone. Women also can improve the production of sex hormones for health, but also for a sex life, you know. So those kinds of things, again, haven't seen them so much in the press or whatever, but, you know.
I'm sure we can probably do a study with the women in our community and get back to you and let you know if there's any change.
Yeah, because that's something that's like we talked about. How do you measure things? Things like that, things that which are quite, you know, you have more of an awareness of those things. I think things like kind of like sex life and sleep and mood, you know, these are things that we kind of have more, we can kind of gauge what's going on. We know if we have a good night's sleep, you know, we kind of know how we feel about our bodies in that way. Yeah, it would be cool. You can put it out to your ladies and kind of do a little study on that because, yeah, you know, there's kind of a lot of growing evidence for the use of it in increasing testosterone. And, you know, and since Ben Greenfield put out that piece, whenever I go to fairs, you know, that's the first thing men ask me, you know, where do I put it to increase testosterone? You know, and it's obvious where you put it, but I think it's the same for women. You know, you can put it there for increasing all of those.
Well, I wonder how it would affect estrogen or progesterone or pregnenolone, and see if those three, or even see how it impacts an imbalance. So perhaps we could do a study where you look at your Dutch panel test. So you look at your hormones at one point in time, and then you use the panel, you use a flex beam for a couple of weeks, then retest again, see how that looks, see if that, you know, if you don't change anything else. Now, granted, hormones are finicky and every month is slightly different. And, you know, it could be that because of everything that's going on in the world right now, we are so stressed out, but it would still be an interesting baseline as a hormonal panel test before and after, changing just one thing, changing just use of the flex beam.
Very good. Well, like I say, if you did it, say you were at the same point in your menstrual cycle, like do you have the flex beam, you were the same point and then tested, I think it would be a valid test. You know, and I think that's why things like, you know, neurodegenerative illness, you know, kind of women seem to suffer from it more. It seems to be after menopause where you're not producing these hormones, you know, they seem to have a protective effect on women. And so there's every reason why you would want to kind of keep the production of your hormones stable. Well, for lots of reasons, but that's one of the reasons, you know.
Have you seen the study that what they're saying is that estrogen can actually help with COVID? And so they're starting to take a look to see whether estrogen can be used. So a lot of COVID patients are males. And so it doesn't seem like it's impacting women quite as much. It still obviously is impacting, but not as much. And so they're asking the question, could it be that the estrogen hormone is actually a protector? And so therefore, could we actually be giving estrogen to men who are sick? many men that I've told that study to or the news about, they're like, I don't want to take estrogen. No, thank you.
I'm not sure if it's a good idea to give men a lot of estrogen, but yes, I mean, it certainly does seem to be protective. Estrogen does seem to be, because women tend to be more resilient on the whole, certainly, pre-menopause. So it would stand to reason that, yeah, that may be an interesting avenue to pursue. But certainly I think from a point of view of maintaining your health and having good amount of estrogen and all of those kinds of steroid hormones, something like red light, which has been shown to have an effect on that system specifically, would be a good thing to do.
Yeah.
But yeah, it's interesting with COVID, isn't it? Because kind of everybody's focused on that and what does and doesn't have an effect. And I know I'm kind of pulling together some stuff with like looking at red light, like for inflammation and maybe helping with, respiratory problems. So yeah, it is interesting to see all of these different things coming out. We're kind of at a strange point in the world where everyone's focused on one thing. And I think that's interesting because what's going to come out about it? This whole thing about estrogen, that could have impact on a lot of different illnesses, couldn't it, really?
And what's interesting too is that this sphere of biohacking and health optimization, and it's almost like everybody is becoming that because we're saying, well, can we stack these things? So, there's studies saying potentially hyperbaric oxygen can help with COVID.
Yes.
Okay, well, can you get into a chamber and then also have a flex beam on you as well at the same time? Can you stack it with methylene blue? Can you stack, how many different things?
Ozone, methylene blue, hyperbarics, red light. If you could get all of that going, I think, that's a winning formula.
Yeah. So while we sound crazy or sound, on the fringe, it's almost that this fringe is saying, actually, this is the way forward rather than some of the other, be it pharmaceutical drugs or be it other ways of Western medicine that has been modern, quote unquote. It almost seems that we are going back and realizing that the natural healing ways of oxygen, of light, of cryotherapy could be the way forward.
Yeah, I think so. And really, whatever they discover about this, to come out of this with a strengthened immune system, that's super cool. I mean, what we really need right now is a lot of people with really good immunity and good immune systems. Whether or not you can treat the virus, even if you can just build your own immune system using these things that we just talked about, it's going to set a lot of people in good stead to kind of help with that effort.
Absolutely. A couple of rapid fire questions for you, if you're open to that.
Totally.
What would you tell your 15-year-old self?
Oh my goodness, my 15-year-old self. Well, I think I've kind of gone the long way round to kind of get to this point. It would be nice to have kind of gone straight there and looked at some of these more, paid more attention to some of these more natural healing practices and kind of focused on those things to start with instead of going kind of this circumnavigous route that I took. But yes, I think that would be nice. That's what I would say. Look more at these natural things. I saw someone the other day who'd done a degree in forest therapy. And I thought, wow, I didn't know that was a thing. I could have done that from the start.
I don't think that existed until probably this past 3 years.
Yeah, it probably didn't. Yeah, certainly not in England anyway.
But at the same time, I hear you. And also at the same time, the only reason why you're able to get and reflect on it now is because you've been on the path, right? Yeah. And you've also had so many different avenues that have even led you to say, you know what, actually, this is the truth, right? This is where you need to be. So, all right, if you could wave a magic wand and change one thing about women's health, what would it be?
Oh, I don't know. I think I would take away a lot of the stigma that's involved in talking about it. I kind of think it's one of these things, especially here in the UK, it's all a little bit embarrassing talking about women's problems. I think I'd take all that away and let's just have some direct, frank discussions about things.
I think we're going there. We're getting there. It's just, it'll take time. We're starting to say this is just facts rather than the stigma associated with it. This is the facts of this is what a menstruation is, or this is what, this is what sexual health is, or this is why, all the different elements of female health or women's health are starting to get boiled down to this is the symptom, this is the facts, and therefore it doesn't feel as difficult to talk about it. It still has a way to go, but
it still has a way to go. And I think the research needs to back it up. There needs to be research which kind of separates the gender differences out, because it's hard to find, it's hard to find any data where you kind of people have even considered that.
I think that's the biggest challenge and that is the plight that needs to change, because we're realizing that if you look at Alzheimer's, it's presented differently. So it's not a women's health issue technically. It is a grander, bigger thing, but the research needs to be done specifically by gender, right? It needs to be, because it presents so vastly differently.
Exactly. Yeah.
Last question. What has been one teacher or book that has changed your way of thinking?
My favorite teacher, certainly in the last few years, was a lovely lady called Mei Wan Ho, who I was following for a long time, and I'd been given her books, and she wrote about quantum coherence and the quantum jazz of life. And she was she was an academic lady. She taught at Open University, but she also painted and did art. But she talked about, if you've got a really good hypothesis, it's going to be very beautiful. It's going to be artistic. And that's how you know that you've got a good one. She kind of spoke like that. And I got to meet her when I was kind of doing another project, a biohacking project. And she was just wonderful, explaining the interconnectedness of life. And that really did help me kind of understand a lot of these concepts. She also wrote books about water, and so the whole water thing is very, very interesting, and she makes it super interesting by the way she writes about it and talks about it. So yes, I would say Mei Wan Ho.
Okay. We'll have to get you back to talk about water.
Yes.
I feel like this is another passion of yours that we don't have time to talk about now, but that's just going to be a separate combo. Perfect. Cool. Where can people find you? Where can people learn more about FlexBeam? Tell us.
The company's called Recharge. It's based in Thailand, and I'm kind of in between Thailand and UK and the States and hopefully Spain soon. But the website is theflexbeam.com. I think we're going to give your audience like a 20% off the FlexBeam because it's a new product. And it's cool to get it out to early adopters, to people that are interested in using this kind of new tech. So I think you're going to have a code for that and a link to the company.
Yeah.
So watch this space. We're kind of on Facebook, the FlexBeam. We're on Instagram. We're kind of doing stuff. It's a fabulous team. It's a fairly large team, even though it's a startup company. So I think probably people in the biohacking. So people can come find us in person. But in the meantime, online, flexbeam.com.
And we'll hopefully see you soon as well, Sarah. This has been wonderful. Thank you.
Thank you. It's been great. Thank you, Dasha.
Likewise. Cool.